are clamp jaws 1, 2, 3, 4. So 8.18 divided by 4 is the current that you would get. Hey folks, welcome back to the show. For those of you that are new, my name doesn't really matter. It might be Luke, we're still not sure. But anyways, today we're going to be getting into all of the different test settings on your MESTEC digital clamp meter. Views for amp clamps on this show are typically really low, but I still do them. So hopefully if you have an amp clamp and you're wanting to get the most out of it for your troubleshooting or whatever your specific electrical troubleshooting need is, why don't you grab a snack, have a seat, and let's dive into this amp clamp. All right, the MESTEC. I haven't had them on the show before. All right, let's take a look at your leads. Your lead, your meter leads and the quality of them. See how there's some discoloration here? I know it's like little stuff like that, but the quality of your leads can often be an indicator of the quality of the meter itself. I always pull these caps off, but don't throw these caps away. You'll need those for higher voltage areas. They don't feel too bad. Really stiff leads is something that you don't want either. You want really loose. Yeah, these aren't bad. These aren't bad. So your thermocouple leads, these are an indication. These are the type of leads that you don't want to see. So a couple red flags coming out of the gate. It looks like they've done what they can to try to beef them up. The problem with this style lead is you plug them in and then you go to unplug them. Unless you unplug them directly from this part, if you tug on this here, then your thermocouple, I mean, it can be really sensitive. So it seems like they've tried to beef it up. I always like to see thermocouple leads be like this. They're clearly labeled for common and positive. It tells you the type, K-type. It's very obvious, and it's one nice block that you can pull out together. And if it's not like this, then to an adapter that has a blade style. Those are the two common, like, industry standard ways that we like to see thermocouple leads. So not the biggest warm and fuzzy just based off of what I've seen so far, but they do give you a little screwdriver. That's nice. I also, too, I don't remember the price point of this meter. So I got to take that into consideration, you know, depending on what this is going for. And then let's take a look at the meter. Okay, nice. No screen protector on it from shipping. Nice little clamp. Okay, we're going to have a flashlight, QC passed. Not all these LCD displays are built the same. Some are really weak, and some are nice and strong. The thing that I kind of look for in a display is at an angle and how much glare, which for filming these videos, we're always going to be fighting a certain amount of glare. Okay, let's see, off position. There, okay, there's a couple things that I like right off the bat. I like a double display like they have here. We have hertz and our amperage measurement listed. Listed together. And that's going to become more and more industry standard. That hasn't really hit the big box store meters yet, but all the ones online, that's becoming more and more common. That's our hold. If we hold this down, there's our flashlight. Let's see. Huh. Yeah, kind of a weak light, but at least it's there. Some of the amp clamps and stuff I've seen, they'll share the same molds and you'll see a light port there that's just blacked out. Okay, and that's the actual backlight. So this is, I just saw in here, this is a 6,000 count meter, which is actually pretty nice. I can't remember where it said it. It's like page 1 or something. 6,000 counts. AC/DC auto ranging, which is pretty good. We are going to learn about taking amperage measurements, and then we need to learn a little bit about why the meter count is important and manual ranging meters, because the amp clamp portion of this meter you're going to see has 2 different selections. It has a 600 amp and a 60 amp. And when you see numbers like that on a multimeter, I want you to get in the mindset of it can measure up to 600 amps or it can measure up to 60 amps. And it's going to do this at a different level of resolution. I want you to think about it kind of like a microscope. When you set up a microscope, you usually have the glass like way back here, and you got stuff on your petri dish down here, and it's kind of blurry. And as you dial in the microscope, things come clearer and clearer into detail, into the picture. It's kind of like with our meter. On the 600 amp range, we can read a lot bigger number, but with less detail. And then as we dial into that 60, then we're starting to refine our measurement. Now, what I would like to see on an amp clamp like this is I'd also like to see a 6 amp setting, because then that would give us even finer detail. You would be surprised at how little the current measurements that you're going to be taking actually are going to be. And for a lot of them, they might even be too small for the meter to be able to accurately read the amperage that you're trying to. Having an up to 6 amp, with it being a 6,000 count meter, that would be able to read to the thousands place, which would be really nice. But we don't have that option here. So since it only goes down to 60, that measurement will only be read to the hundreds place. So you can see like picture 60.00. And then for our 600, that decimal place is going to be all the way over here. So those are things that we can only read to the tenths, right? We're going to go over how to do your amp clamp measurements and all that stuff, and then we're going to go over the rest of the settings. If you don't know, what you should be pairing with your amp clamp is something like this. It is called a line splitter. You can get them at your big box store or online. This one in particular has a 10 times 10 magnification. So what this has inside of it is a conductor that's coiled up 10 times. And when you measure it with your amp clamp, it's going to be 10 times the current than is actually flowing through here. You can see I got a little battle scar on here from doing some testing. So you'll want to pay attention to that. If you do get a line splitter, they'll oftentimes have a certain amount of magnification annotated on them, and you might not know about that. And so when you take your measurement, you'll be like, wow, my toaster is drawing 45 amps. Well, it's times 10. So it's really 4.5 amps. And they do this to help with accuracy. Like I was saying earlier, with those really, really small measurements, you know, if you're measuring something that's only like an amp or half an amp, it might not be a strong enough magnetic field for the clamp to accurately pick up. And so you'd want to use some type of magnification method, either through your line splitter, or a little trick that you can do is whatever conductor you're measuring, your hot or your neutral or your positive, you can wrap that conductor around your amp clamp, and that's the magnification times. So if you're going to be making amp clamp measurements of things that you would find around the house that you would just plug into your outlet, you don't want to go around, you know, having to cut open your power cord so you can get to one conductor or the other. You're going to want a line splitter. A part of that is when we're making amperage measurements, you can't measure your hot and your neutral at the same time, or your positive and your common. The magnetic fields are going to be opposing, whether they're swapping back and forth or just in a steady state opposing each other. And that's what the amp clamp is trying to measure to tell how much current is being drawn. If you measure both the hot and the neutral at the same time, or your positive and your common at the same time, they cancel each other out and you're gonna see a 0. And we're also gonna show example using a line splitter and without a line splitter to try to kind of give you a little bit of variety so that you can have some ideas for whatever you're trying to measure the current with. So we've got our little outlet here. Put this in here and we're gonna measure, it's gonna be out of frame, but I've basically got this giant like AC motor tied up. It's got a little pulley on it, so it has a little bit of a load and it draws a halfway decent amount of current. And that'll be, think of that as our load. That's a toaster, it's a washer machine, it's, you know, whatever you got plugged into your outlet, and we're going to make a measurement of it. I'd also recommend some electrically insulated gloves and some safety glasses. Something else that we're gonna be utilizing when we're doing these tests, you have this hold button on the side. So I'm gonna turn on the motor, I'll make a measurement, I'll press the hold button, and then that'll hold the value so that we can talk about what's going on with the current without the motor having to run. And it's also just a really handy setting for you to have for making your own measurements. Let's see, we got that. It's in the off position. Okay, and remember, this is in the line splitter with the ×10 magnification. So whatever reading we get here is going to be 10 times the actual amount of current that the motor is trying to draw. Okay, let's take a look. That was kind of early on. So you see 93 amps of current draw. Remember, that's ×10. So we would take that number divided by 10. It's really 9.35. Let's do it on the next setting down. No, we can't because it's too high. So that's where you would use that 600 amp setting, is we're well over the 60 amps that we're rated for in this one. So if we had it in this setting and we tried to take our measurement, it's going to say OL. Let's show that here. What that OL stands for in this context is going to stand for out of limits. It's saying, hey, I'm only rated for up to 60 amps of current measurement, and you are well above that. I'm OL. I don't understand what you're trying to measure. And then something else that I wanted to touch on too, while we're looking at it, is let's go back to our 600 amp setting. And something that you should see is right when I turn on the motor, there should be a much larger number on the display at first, and then we'll let the motor run for a minute, for a few seconds, and you'll see that number start to settle down. And that is the steady state, the steady current draw. And we're going to talk about what's going on there in a second as well to help kind of clear that up. So let's run it for a minute. So our steady state current draw is really 7.73 amps of current. You saw in there probably originally it was like 110 or 111. I'll have to look back at the footage to see. And that's what's known as the inrush current. And there are amp clamp meters that are designed specifically for that early measurement. So let's talk about what it would look like if you were looking at this on an oscilloscope, what the waveform would look like that you're actually measuring. When you first turn on this motor, there's a giant spike in the amount of current that it draws. There's a bunch of different super fancy reasons why that are outside of the scope of this, outside of this video, but I want you to think of like, it needs that initial kind of jump start to get the momentum going so then it can, you know, kind of do its thing. Like when you're trying to push something heavy, you got to exert a lot of force at first, and then you can kind of let off and then kind of just let it do its thing. That's kind of what's going on here, but on a different level, right? It's needing that initial push to get the object going, and then it's got its steady state. So that's how to make a measurement with a line splitter. Keep in mind that magnification, because that'll bite you in the booty. You'll be like, oh man, this thing's drawing like 150 amps. Well, it's probably drawing closer to 15 amps. It's just times 10. I think other ones have like times 5 or, you know, whatever. They have different values, but just something to keep an eye out for. If you weren't going to be using a line splitter, then yes, you're going to have to find access to that conductor, and you can use either the hot or the neutral, just not the ground, right? We want a current carrying conductor, and yes, your neutral carries current, and your ground is not supposed to. Your ground is there for safety. So we'll omit the line splitter for now. We'll plug in, I've got the same motor hooked up, but now I just have access to individual conductors. We'll release this hold button. I have nothing going through. If you have this thing kind of going all over the place, because there's a lot of noise in the room, like electrical noise, that's what the 0 button's for. So you can zero out your meter before taking a measurement. You'll notice that sometimes it'll get stuck on a number. So let's take a measurement. We're going to try it at first at the 600 amp setting. Remember, we're only going to be able to look to the tenths, and then we'll drop it down to the 60 amp, and then we'll be able to see the measurement to the hundredths, and then it's not times 10 magnification. I noticed our frequency was jumping around a lot that time. Okay, we've got a way smaller number here. Only a 5.8, that seems really low. Well, in this big setting, we're not gonna get the detail and the accuracy that we're after. So let's bring it down to the 60 amp, and let's see if we can get a more accurate number of what's actually going on here. 6.25, okay. This still seems a little bit off from what we have with our times 10 magnification divided by 10 versus just with the conductor. And this is where I wish they would have a third setting with, you know, 6 amps or whatever. And so we could really get that low end dialed in and see like how accurate this is. But with that being said, that's how you would make an amperage measurement with this clamp. Let's try something small and something DC. Okay, so since we're going for something DC, let's make sure that we hit the selection button. That'll bring us to the DC setting. Let's just kind of get a feel for what's going on here. DC is where you're really gonna see it float around. Let's make sure to zero it out. I'm sure in the manual it has very specific, like, you know, make sure you zero it out before every single measurement. And with DC, it's probably going to be directional. Let's hold this. Now, I'm seeing on my power supply, I'm only outputting 2.024 amps. So it looks like we're a little bit off. And then on top of that, notice that we have this negative sign telling me that this amp clamp is directional. At least it's going to be for DC measurements. Okay, and then it looks like when we have it in the proper direction. So the way that I'm switching the directions of the polarity is like this or like this, or you can change the conductors. But now I'm showing with the proper polarity 2.03, which is much, much closer to what the power supply is outputting. Power supply is calling out 2.025, and we're at 2.05. I'd say that's really close, really accurate. And then something you can try, you know, let's see. Well, I guess that would count that as 2, excuse me. So we have the conductor going through, and then it's going through again. So we've doubled. Now we should have tripled. 4. So it's going through our clamp jaws 1, 2, 3, 4. So 8.1 1/8 divided by 4 is the current that you would get. So that can be really handy for very small loads that your amp clamp is really struggling to pick up. Let's get into thermocouple. Pretty straightforward. Black will go into the COM and red will go into the input port. And remember, when you're removing this style from the plastic part, always, or you'll damage this. So it looks like it defaults to Celsius. If I hit the select, I can bring it into Fahrenheit. And then something I like to do before I ever take a measurement with my thermocouple is I like to actually put my fingers on the tip and then make sure that my temperature increases so that I know that my thermocouple leads, have good integrity and I haven't broken them by yanking on this part too hard. So pretty straightforward, super handy function to have your thermocouple. Let's go into capacitance. Now this seems like most amp clamps are pretty popular amongst the HVAC techs, and it seems like this is kind of more of an HVAC specific type of unit. So we'll use, this is a run capacitor for an AC unit. It's gonna look like I'm handling this somewhat carelessly. It's just because the actual amount of capacitance that this is rated for is very small. Only for 35 microfarads and 5 microfarads. The reason why it looks so beefy and scary is to handle the amount of voltage that it's rated for. But the actual capacitance is very small. So you'll always want to short out your capacitors before testing them with your meter. And that way, that's for your own safety and so you don't accidentally barbecue your meter. We are on the capacitance setting, and why don't we just go ahead and take a measurement. So on this capacitor, there's C. C is not for cookie, C is for COM, and that's where I'll put my black. Screwed up like the easiest thing to do, and that's to put your meter leads in the right port. That's to put black into COM, and then I'll put my other lead. This is the Herm for hermetically sealed. We'll give the meter a minute to charge up, and then it comes back as 35.25 microfarads. That's what that funky looking U is. And then we can go ahead and test the other capacitor. Black lead's still on COM, red lead's on fan. Give it a minute, and it comes back 5 microfarads. Very cool. And then if you're using it instead for like as a hobbyist, I always like to do this test. It's a 6,000 count meter, and this is a 680 microfarad capacitor. There's black is for negative. If you screw this up, it's not a big deal. It shouldn't hurt anything. Just make sure it's discharged. That's the biggest thing we want to look for. And so because it's only 6,000 count, and this is over 600, this is something that has screwed me up a lot. So I want to, and it's even in my old videos, you can watch me screw it up. It says 0.632 millifarads. All right, it says 0.635 millifarads, and our capacitor is rated for 680 microfarads. So this is where we want to really pay attention to our units of measurement, because 0.635 millifarads is equal to 635 microfarads. And our capacitor is rated for 680 microfarads, and it needs to be within plus or minus 10%. So the capacitance of this is good. I've seen that a bunch of times and I've messed it up, and I'm here to right my wrongs. Continuity, resistance, and diodes. It looks like it's going to default to resistance. And remember, it's not just resistors that have resistance. Any type of like electrical load is going to have a certain amount of resistance. Like we can take this little motor here And we can check its resistive value to see if there's an open in the motor. Okay, and it looks like it comes at 1.1 ohms. So there's that. I wish it would either have a dedicated continuity setting or it would default to continuity, because that's what you're really going to be using your meter for. Continuity is the next setting though. You know, you can check to see, okay, this one goes to red, and then black goes to here, and then they don't short to each other. So you're just looking for some kind of flow. Like if you have a big bundle of wires, or you're trying to, you know, discern who's who out of a bundle. And then we can go to our diode setting. That's what that little arrow with the line through it is going to be. And if you notice, I was just hitting the selector button to cycle through different settings, right? So then we can just take a run-of-the-mill diode. I've got my stripe of the diode on the right side. We'll test it in both directions, like that. And that's going to be the amount of voltage drop we have across our diode. We typically want to see between 500 and 800 millivolts of voltage drop, which that is 0.586 volts, which would be 586 millivolts. And then we can test it in the other direction. And we get an OL for open loop instead of out of limits. Open loop basically means, you know, you need a circle, right? You need a complete circuit for electricity to flow. Open loop just means that it's an open circle, no chooch. All right, and now for the easy stuff, I mean, volts DC, right? You want to be careful of your lead polarity, or you'll get that negative sign. My black lead is on the common, my red lead's on the positive. And then, you know, you can do AC measurement, and then it's got the hertz. Does it have, it doesn't have any kind of hertz there. And we can always, you know, I like using a dedicated outlet tester for measuring out of an outlet, but that's not always going to be an option. Man, I'm really hitting that hold button. It kind of depresses a little too easily. So if you want to check, use the probes to open the doors. And we have a reading. Make sure when you're doing something like that, don't touch those leads together or short them out or touch them against something else. It can be really easy to do that. Then while the doors are open, we can pull one out. We can check our potential to ground. There it is, 120. And then we can check our potential between ground and neutral. And then, you know, that's how you can kind of discern who's hot, who's neutral, is utilizing a ground conductor. If you don't have a ground, you know, find one and bring it to the area that you're testing, and then you can use it like that. There should be some kind of ground around the house, you know, somewhere on the property. Should be some type of ground somewhere that you can run like a little extension wire to, like an outlet, if you're trying to figure out what's hot and what's neutral. But there you go. So I hope this all made sense. If anything didn't, please give me feedback down in the comments section. If you guys are learning this stuff, I've got a bunch of videos, a lot of different shorts on different electrical concepts, and videos on a bunch of different meters, types of meters, inrush, current, amp clamps, and just kind of everything under the sun. So please go check it out. Let me know down in the comments what you think, and I'll catch you on the next one.